So welcome back with 1.4 linear functions and slope. This section's nice in a way because a lot of this is going to be visual. A lot of this is going to be algebra 1 and algebra 2. You also should have seen most of these types of equations before. So there should be some areas here that you're really strong with, or if you need a refresher, please ask in class. The in-class time is definitely for asking questions, looking over the material, just fine-tuning anything that you might be unsure of or anything that you need to practice. So a lot of the terms here we have seen before: calculating slope, writing point slope forms of equations of a line, slope-intercept forms of a line, writing and graphing those, graphing horizontal and vertical lines, which we did, I think, in 1.1. So that's coming back again. Recognizing and using the general form of lines equation, we actually won't see this, so you can disregard that. Using intercepts to graph the general form of a lines equation. We'll use intercepts, but not so much the general form. Finally, modeling data with linear functions and making predictions. So if you get stuck at any point in time or you need a refresher on algebra 1 and algebra 2 graphing, this box here should be able to help you out. Just so that we have it on hand, I'll also include the slope formula, y2 minus y1 over x2 minus x1, or you can call it rise over run. Down the road in this course, we will be using the idea of delta, so the change in y over the change in x. That's another way you might have heard of it. So with this first equation or first example, we're being asked to write the slope-intercept form of the line passing through the point -1, 5. We're definitely dealing with a point, also dealing with an x-intercept of -4. So there's a lot that we can already use to our advantage here. If we have the graph on hand, I know this point, we can graph that out. We don't really have a set step-by-step procedure for the types of problems here because it is building on a lot of algebra you should be familiar with. So we'll just go with what we can. So we know we have this point, -1, 5. We know we have this x-intercept of -4. So this is intercepting the x-axis seen here. And so there are a few options that we could think out as far as solving this. We know that we have 2 points that are on the line. Building off of how we can work with a concept, we can sketch out the graph. We can also use a table. So we have a little bit that we can do here. I'll give you a moment to think out which equation might work the best if we're trying to make this happen. So evaluating this standard form, that's really for x-intercepts and y-intercepts. We don't quite know the y-intercept yet. So slope-intercept, that's kind of out the door too. With that being said, we do have 2 points, and we don't necessarily know the slope, and that's what we need if we're going to go to the slope-intercept form. So keeping this in mind, whether you use slope formula or rise over run, let's see if we can get a hold of this slope. So if I start at the x-intercept point of -4, 0, I'd start to run 1, 2, 3 units. So my run is +3. We start to rise 1, 2, 3, 4, 5. Our rise is +5. So we can start to make some sense of this line. We know that our rise is 5, our run is 3. So we can then say that our slope is going to have to be 5/3. And that's for certain because we just evaluated the rise and the run given 2 points. So from here, we have some options if we're going to slope-intercept form. Again, we don't know the y-intercept yet. So I think using point slope form is the best option to actually write this out at first. So if we're using point slope, I know that it starts with y terms. We're then subtracting a y coordinate. For this one, I'm going to use -4, 0 because that'll make my life easy, having one of the terms be 0. This is then equal to slope 5/3, parentheses with x. We're then subtracting the x coordinate that corresponds with 0, so -4. From here, a little bit of algebra. So this subtracting 0 can kind of go away because we can't really add or subtract 0. 5/3, we can distribute that to x. So 5/3 x. If we're subtracting -4, this is as if we're adding on 4. So we could rewrite this as 5/3 x plus 4. We can then distribute 5/3. So 5/3 to x, 5/3 to 4. So multiplying here, keep that in mind. 5 times 4 gets us 20 in the numerator, keeping -3 in the denominator. So although we claim that we were going to go from point slope form to start there and then go to slope intercept form, this one was nice because the y coordinate we used for the point was already 0. So this is totally fair game. This actually made our workload a lot easier. So we now have the slope intercept form. And this is going to be our final answer for this one. So this section's pretty vague with how they want you to start off the problems. Luckily, if you really know what's going on, if you have the visuals on hand, if you have a calculator on hand, there are tons of ways you can approach these. This is just one approach that we took. So 5/3 x plus 20/3. That's the equation we can get. With the next problem, we're being asked to give the slope and the y-intercept of 6x minus 12. You might want to take this time now to look at this equation and think, what's missing? So what's missing from this equation here? Well, we know we have an x. We don't have a y term. So y is missing. With that being said, we could still try to take this further. This looks like something we could solve. So if we have 6x minus 12 and this equals 0, trying to solve for x, 6x is going to have to be equal to positive 12. X is then going to have to be 2. But this doesn't necessarily give us anything about a y-intercept or a slope. So with that in mind, this does seem like something we can graph. We've graphed this previously in 1.1 where it's just x equals 2. So it's the one line where everywhere on this line x equals 2. And the only line that's going to make sense of this just happens to be vertical. From here, we can see that there's no y-intercept. Because this is straight vertical, it's not going to go to the left or to the right, just straight up and down. We can also say that for the slope, well, you can't really walk on a straight vertical wall, so the slope is undefined. And that's all we can really say about this equation. It doesn't ask us to graph this out. If we were to plug this into a calculator, we wouldn't get too far, but with this one, this is as close as we can get to graphing. The slope, we can still evaluate it even though it's a vertical line, and there's unfortunately no y-intercept.